These are the notes for section 5.2, right triangle trigonometry, in unit 8 of Algebra 3. So in geometry, you've learned about right triangles and, well, even before, but right triangles are a triangle that contain a right angle. The angle makes 90 degrees. So it's always marked with a 90-degree symbol. The side opposite that 90 degrees is always the hypotenuse. That never changes. The hypotenuse is always the largest side. The two legs, it doesn't matter which one you call A and which one you call B when you're doing Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared, or A squared plus B squared equals C squared. But if we're going to use this in trigonometry, we need to identify which leg we're talking about. So if we were to identify an angle, and in trigonometry, most times we use Greek letters. I'm going to call this the angle right here between this hypotenuse and this leg, and I'm going to use the Greek letter theta. So theta is just it's a variable that means usually angle. And there's other variables that you can use. It looks like a circle with a line through the middle. So if this is my angle theta, opposite theta, if I take and draw from this corner, this vertex, straight across, this is going to be the opposite leg. And this one that includes the side that is touching that angle would be the adjacent leg. So when you're doing the trigonometry ratios, sine of theta is going to be the opposite side over the hypotenuse. So it's the ratio of the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And these you do have to know. A lot of you learned SOHCAHTOA. And there's lots of ways to remember this. But sine is opposite over hypotenuse, SOH. Cosine, adjacent over hypotenuse, CAH. Tangent, opposite over adjacent, TOA. And then we are going to add to that as well the cosecant. The cosecant of theta is going to be the hypotenuse over the opposite. So you're just taking the hypotenuse and put it over the opposite. This is the reciprocal of the sine. That's why I always write it directly across from it. The secant, so secant of theta is the hypotenuse over the adjacent. It's the reciprocal of the cosine. It's not the opposite. It's the reciprocal. There's a huge difference. Cotangent is going to be adjacent over opposite. So it's the reciprocal of tangent. And there's some words you've learned in math that might mean different things along the way. But to me, right now, reciprocal is a really important word for you to understand. It just means you take and flip a fraction, and it's not the opposite. So we also use Pythagorean theorem with these. So Pythagorean theorem would be leg squared plus leg squared equals hypotenuse squared. So most of you know it as A squared plus B squared equals C squared. So my example down here is I have a triangle, and I have one side is 40 feet, one side is 25 feet, and I don't know the other side. So I'm going to use Pythagorean theorem. So I know that 40 squared plus 25 squared is equal to x squared. 40 squared plus 25 squared is going to equal 2,225. And we're going to write it as a radical. This is going to be the square root of 25 times the square root of 89 So x is going to equal 5 square root of 89. And you'll be happy. The problems that you're going to do out of the book first aren't going to have any square roots, but they don't always come out this nice. So if I were looking at this diagram right here, and I wanted to find the ratios, so sine of 38 degrees is going to be the opposite side over the adjacent, or the hypotenuse. So what's important is that there's no units. This feet is the same in the numerator and the denominator, so we get rid of those. 25 divided by 5 can reduce. And then we're going to rationalize the denominator. 5 square roots of 89 in the numerator. Square root of 89 times the square root of 89 is going to be 89. So that's sine of 38 degrees. Cosine of 38 degrees is going to be adjacent over hypotenuse. We can reduce 40 over 5, which is 8. Rationalize the denominator. So 8 square root of 89 over 89. Tangent of 38 degrees is going to be opposite over adjacent. So 25 over 80, or 25 over 40. And when I reduce that, I get 5 over 8. Then I could do cosecant of 38 degrees. Cosecant of 38 degrees is 5 square root of 89 over 25. So hypotenuse over opposite. So this gives me square root of 89 over 5. Secant of 38 degrees is going to be hypotenuse over adjacent. And I can reduce that fraction. And then cotangent of 38 degrees is going to be adjacent over opposite, and I can reduce it. So those are the 6 trigonometric functions, and that these ratios are specific to this triangle that I had here. And then you're going to have to be careful. If I turn this around in different orientations, you still have to look at what angle you're talking about. And just because I turn the triangle around does not change the opposite side. If I were asking for the sine of 52 degrees, 52 degrees is here, so the sine of 52 degrees would be 40 divided by 5 square roots of 89. So the opposite means the opposite from the angle you're talking about. In solving right triangles, well, let's look at let's look at special right triangles first, and then we'll solve some triangles. There are special right triangles, the 45, 45, 90 degree triangle. And there's different ways to memorize this. I was really bad about memorizing this, so I just always tried to figure it out. If this angle is 45 degrees, that side is x. This angle is 45 degrees. This angle has to be the same as that. So if this were c, the hypotenuse is c, I know x squared plus x squared equals c squared. So 2x squared equals c squared. If I take the square root of both of these, I get the square root of 2 multiplied by x is equal to c. So in this example, it's written x multiplied by the square root of 2. So you don't have to memorize it, but it helps. With the 30, 60, 90 degree triangle, 30, 60, 90, and I should have drawn that in first as a right angle, although it did say it. There isn't an easy way to come up with this ratio as it is in the 45-45, but there's one thing that I always remembered. This 30-degree angle, I know that this side, opposite 30 degrees, is always 1/2 the hypotenuse. So if the hypotenuse was 10, I know this is going to be 5. So if I wanted to use that as an example to show you how I remembered it, say this is 10. Let's make this 30 degrees here. I didn't draw this to scale. And this is 60 degrees. This is 10, then I know that this is 5. And I know 5 squared plus, we'll call this x. X squared equals 10 squared. So x squared equals 100 minus 25. So x is going to equal the square root of 75 is the square root of 25 times the square root of 3. So this is 5 square roots of 3. So this side here is going to be the square root of 3 times 5. And it's usually written 5 square roots of 3. So let's solve right triangles now. The first thing we're going to do is we're going to solve for a side. And in this example here, I have angle A, angle B, and angle C. Angle C is your right angle, so 10 is your hypotenuse. So if it helps, you can label this H for hypotenuse. If this is the angle 36, then A is going to be the opposite, and B is going to be the adjacent. So if I want to find A, well, I've got the hypotenuse, and I need to use the, I want to find the opposite. So I'd have sine of 36 degrees equals A over 10. To solve that, I'm going to multiply 10 times the sine of 36. And then I'm going to use the calculator. So the first thing we need to do is go to your mode and make sure your mode is on degrees. By default, the calculator for the TI-84 is always on radians. So I'm putting it on degrees. Then I want to type in 10. And you could say times sine of 36. And I don't need to use the degree symbol. I'm just going to enter it there. And I get 5.877. I'm just going to go to 2 decimal places. So I get A is equal to 5.88. And this did not have units, so it just stays 5.88. If I wanted to find the side B now, I could use Pythagorean theorem. I know A and I know C, and I could find B. But it's just not usually wise to do that, because what if I made a mistake finding A, then that mistake would follow me along and also make a mistake at B. So I'm going to use trig. So this is the adjacent, and I have the hypotenuse, so I'm going to use cosine. So when I cross multiply, I get B is equal to 10 cosine of 36 degrees. Plug that in the calculator, and I don't need the multiplication symbol. I get 8.09. I know when I've taught geometry in the past, students struggled with this, and I wasn't sure why. So hopefully you guys are fine with it. This next one, I've got 2 sides, and I can find the third side with using Pythagorean theorem. So I know A squared plus 24 squared equals 25 squared. So A squared is equal to 25 squared minus 24 squared is 49. So A is equal to 7. But I also wanted to use this to find the angles. If I want to find angle A, I'm given the adjacent and I'm given the hypotenuse. So I could say cosine of angle A equals 24 over 25. Then I need to use inverse cosine. So angle A is equal to the inverse cosine, and I'm going to use cosine to the -1 of 24 over 25. So this is different from reciprocal, and that's why I said earlier, you've got to be careful with the wording that you use. This is specifically inverse in this case. So I go back here, and my inverse cosine is right here. So I'm going to do second and cosine, 24 divided by 25. And you don't have to make this into a fraction, I just did it so you could see the numbers I was using. And this is 16.26 degrees. And then I can find angle B as well. And there's many ways to do it. I know if this is 16.26, this is 90 degrees. I know angle B has got to be 180 minus 90 minus 16.26. But if I made a mistake finding angle A, that mistake's going to follow me at angle B. So I'm going to use angle B. 24 is opposite. 25 is hypotenuse. So I'm going to say sine of angle B equals the opposite, which is 24 over 25. So angle B is equal to inverse sine 24 over 25. Oops. And I get 73.74 degrees. And I could easily check it because I know that in a triangle, everything's got to add up to 180. Well, I know the right angle was 90. I found 16.26 for angle A and 73.74 for angle B. And they add up to 180. So I'm pretty confident that those are right. During the live lessons, I will give you more examples.